Nuclear fusion. Nuclear fusion is a process in which lighter nuclei fuse together and a heavy nucleus is formed, and thereby energy is released. For example, hydrogen atoms fuse to form a helium atom at high temperature and pressure. At high temperature and pressure, hydrogen atoms fuse to form a helium atom. We know that the protons are to be brought together to form a helium nucleus. To form a helium nucleus, protons should be brought close together. While coming so, they repel each other because they are like charges. To overcome this electrostatic repulsive force, a large amount of kinetic energy is required. So electrostatic repulsive force is overcome by kinetic energy of the protons. Nuclei acquire this kinetic energy at higher temperatures, at high temperatures beyond 10 to the power of 6 Kelvin. When protons are subjected to a very high temperature of the order of 10 to the power of 6 Kelvin, they acquire sufficient kinetic energy to overcome electrostatic repulsive force. That is when matter is in the state of plasma. These temperatures are present naturally in the core of stars. So, thermonuclear reactions are taking place continuously. Thermonuclear reactions are taking place continuously in the core of the stars because the necessary conditions are provided there. And thereby, fusion process is taking place continuously inside the stars. We know that when a nucleus is formed, a small amount of mass disappears and is converted as energy. So, energy is released continuously in the fission process. This energy is 1000 times greater than the energy produced in fission process by the same mass of fuel. This energy is 1000 times greater than the energy produced in fission process by the same mass of fuel. The temperatures required for the fusion are attained by exploding an atom bomb on Earth. If we want fusion process to take place on Earth, if you create conditions for fusion process on Earth, then it is required to explode an atom bomb so that high temperature is created. Hydrogen bomb is based on the principle of fusion process. Atom bomb is based on fission process and hydrogen bomb is based on fusion process. Energy emitted by stars. In the interior of the star, the temperature is more than 10 to the power of 6 Kelvin. The matter will be in the form of plasma state. And thermonuclear reactions will be taking place continuously. In the core of the stars, thermonuclear reactions takes place because the matter is in plasma state due to very high temperature of more than 10 to the power of 6 Kelvin. Sun is a star of temperature around 10 to the power of 6 Kelvin. In stars, it is noticed that thermonuclear reactions are taking place in two different ways, by two different processes. In stars of very high temperature, the process taking place is termed as carbon-nitrogen cycle. In stars of very high temperatures, the process taking place is termed as carbon-nitrogen cycle, and in stars of less temperature, it is called proton-proton cycle. So there are two processes that are taking place. We know that energy is released in the fusion process. So energy is sent out of sun and other stars continuously with this process. In proton-proton cycle, 4 protons fuse to form a helium nucleus. 4 protons fuse to form a helium nucleus, and thereby 2 positrons are emitted along with 24.6 MeV energy. In proton-proton cycle, 4 protons participate in fusion process and a helium nucleus is formed by emitting 2 positrons and 24.6 MeV energy. In carbon-nitrogen cycle, carbon acts as a catalyst. During a cycle, the carbon will be transformed into nitrogen and then back into carbon. It acts as a catalyst, but it will be transformed into nitrogen and back to carbon during one cycle. Here also 4 protons will be fused to form a helium nucleus by emitting 2 positrons and 26.72 MeV energy. Here also 4 protons are fused to form helium nucleus by emitting 2 positrons and 26.72 proton-proton cycle. Bothe and his co-workers proposed this process, assumed to be taking place in stars like Sun. Proton-proton cycle was proposed by Bothe and his co-workers, assumed it to be taking place in stars like Sun. First, 2 protons fuse to form deuterium atom and some energy is released. In the form of nuclear reaction, it is written as 1H1 plus 1H1 gives rise to 1H2 deuterium plus some energy Q1. Deuterium combines with another proton and helium isotope is formed and some energy is released. In the form of equation, nuclear reaction equation, it can be written as 1H1 plus 1H2 gives rise to 2 helium 3 plus some energy Q2. This helium isotope combines with another helium isotope to form helium nucleus and thereby 2 protons and some energy are released. In the form of nuclear reaction, helium 2,3 plus helium 2,3 gives rise to helium 2,4 plus 2 1H1 plus some energy Q3. The reaction is helium 2,3 plus helium 2,3 gives rise to helium 2,4 plus 2 1H1 plus some energy Q3. The total energy released in the process before a helium nucleus is formed is 24.6 MeV. So the total energy released Q1, Q2, Q3, sum of these three is about 24.6 MeV. Along with this energy, 2 positrons are also emitted. The entire process is simply written as 4 1H1 gives rise to helium 2,4 plus energy Q. Carbon-nitrogen cycle. This is suggested by Bothe. This was suggested for stars of higher temperatures. 1H1 plus carbon 612 gives rise to nitrogen 713 plus some energy Q1. 1H1 plus C612 gives rise to nitrogen N713 plus Q1. This nitrogen is unstable it decays into carbon and by releasing some energy, which is written in the form N713 gives rise to carbon 613 and some energy Q2. Then this carbon isotope, it combines with another proton, which can be written as 1H1 plus carbon 613 gives rise to nitrogen 714 plus some energy. This nitrogen 714, it combines with another proton and becomes oxygen isotope. The relation form is 1H1 plus nitrogen 714 gives rise to O815 plus energy Q4. This oxygen isotope, it is unstable and it disintegrates into nitrogen. The reaction can be written as O815 gives rise to nitrogen 715 plus some energy Q5. This nitrogen combines with another proton and finally carbon will be formed. Carbon, helium and some energy will be released. In the form of nuclear reaction, 1H1 plus nitrogen 715 gives rise to carbon 612 plus helium 24 and plus some energy Q6. 1H1 plus nitrogen 715 gives rise to carbon 612 plus helium 24 plus some energy Q6. The entire process can be written in this single form: 4 1H1, that is 4 protons fused together to give helium 24 and some energy. The amount of energy released in the entire process, in the entire cycle, is 26.72 MeV. Here carbon acts as a catalyst. This process will continue till the entire hydrogen is elementary particles. A particle that do not have any structure can be called as a fundamental particle or elementary particle. Electrons, protons, neutrons, etc. are considered to be constituents of atom. These particles are termed as elementary particles. Along with these particles, there are about 200 fundamental particles found through research. An antiparticle is associated with each particle. An antiparticle is associated with each particle. Generally, antiparticles will have same mass and spin, but opposite charge and magnetic moment. Some neutral particles also have antiparticles. So in their case, there is no change of sign or charge, opposite charge. Let us take an example. Electron and positron are charged particles and antiparticles. They will have same mass and spin, but their charges are opposite. Neutrino and antineutrino, they are also antiparticles. They will have same mass, but both of them are uncharged particles. The antiparticles are represented with the same symbol and with a bar over it. For example, nu bar. When a particle meets its antiparticle, they annihilate, giving rise to energy. For example, if a positron meets an electron, they annihilate and reappear as 2 gamma photons. In the form of nuclear reaction, E plus E minus gives rise to 2 gamma. Like this we represent the nuclear. Bosons, the particles which follow Bose-Einstein statistics, are called as bosons. Massless energy particles, photon and graviton, they come under this category. Photon and graviton, they come under the category bosons. The spin of photon is 1 into h by 2 pi and that of graviton is 2 into h by 2 pi. So they are integral multiples of h by 2 pi. Photon spin is 1 h by 2 pi and that of graviton spin is 2 h by 2 pi. Other bosons are pi mesons called pions and k mesons called kaons. Pions and kaons. Pi mesons, k mesons. Pi mesons are pi plus, pi minus and pi 0. K mesons are k plus, k minus, k0 and k0 bar. Bosons follow Bose-Einstein statistics. They include material particles as well as energy particles. So in the category bosons, we find material particles as well as energy particles. Fermions. Fermions follow Fermi-Dirac statistics. Fermions include lighter particles called leptons as well as heavy particles called baryons. Leptons and baryons together called as fermions. Leptons are particles of weak interaction. They include electrons, muons, neutrinos and their antiparticles. Leptons are particles of weak interaction like electrons, muons, neutrinos and their antiparticles. Baryons are heavy particles. Baryons include protons, neutrons and their antiparticles and also hyperons. Baryons include protons, neutrons and hyperons. Hyperons are very heavy particles which include lambda, sigma, omega and xi particles. Hyperons are very heavy particles. Lambda, sigma, omega and xi particles. Sigma particles are sigma plus, sigma minus and sigma 0. Xi particles are xi minus and xi 0. Classification of elementary particles. A overview of the classification. Elementary particles are divided into bosons and fermions. Bosons and fermions. Bosons are photons, gravitons, pions and kaons. Now pions are pi plus, pi minus and pi 0 particles. Kaons are k plus, k minus, k0 and k0 bar antiparticle of k0. These are bosons. Now fermions. Fermions are classified into leptons and baryons. Leptons constitute E plus, E minus, positron, electron, mu plus, mu minus and a neutrino, antineutrino. These 6 particles, they come under the category leptons. Baryons are heavy particles. Baryons are once again classified into nucleons and hyperons. Nucleons are proton, antiproton, neutron, antineutron. These are nucleons. Hyperons are very heavy particles, lambda, sigma, xi, omega particles. Sigma is constituted of 3 particles, sigma plus, sigma minus and sigma 0, neutral sigma. Xi particles, xi minus and neutral xi, xi 0. These are the classifications of, and these particles are fermions. So fermions and bosons together they are elementary particles. Elementary particles can also be classified basing on mass, stability, type of interaction between them, etc. So this is one type of classification basing on both Bose-Einstein statistics and Fermi-Dirac